So good morning, all that have joined us. Then we can actually start from this point. This session is being recorded so that you can actually access it later. It's going to be uploaded. Let me share a screen here so that we can actually begin. Okay, so hope that you are able to actually see. You are able to see the screen that I've just shared right there. This is UML analysis model, and UML analysis model happens to be the last topic, but it has a lot of models to draw. Let's say it has 8 or 7 models to draw. So UML analysis model is our last topic, which has 8 diagrams to draw, meaning that it's going to take us some time to actually go through it. And it's a very, very interesting area. Now, basically, we have done dynamic modeling, functional modeling, and in all these, we were trying to represent the different, the different diagrams that are normally used. We are trying to represent systems using the different diagrams that are normally used in object-oriented analysis and design. So in UML analysis model, it's actually basically like a continuation of all that, and therefore let me just do something here. Okay, so it's a continuation of all that, but it's just a little different trajectory. Basically, the UML analysis model, UML stands for Unified Modeling Language. Basically, it's a graphical language for object-oriented analysis and design that gives a standard way to write a software system blueprint. So it helps us to visualize, specify, construct, and document the artifacts of an object-oriented system. It is used to depict the structures and the relationships in a complex system. Now, UML analysis model, the UML, the Unified Modeling Language, is basically a standard for drawing object-oriented and designs for object-oriented systems or softwares. And therefore, it uses basically visual artifacts, things you can draw, things that someone can see, visual artifacts, and therefore you use those visual artifacts to basically specify and construct the system in full. So that is basically the function, or it is basically the function for UML, the language, the Unified Modeling Language. Now, the Unified Modeling Language is not so different, as I had said, from the previous ones that we have been drawing. Why? Because just like the previous ones that we have been drawing, we have been using visual artifacts, haven't we? We have been using visual artifacts to specify and construct and document the elements or the components of a system, right? We have been using all those. So it is not that this is different. It's just that we are just basically continuing with the same, okay? And therefore, the UML, it came up from in the 1990s. And basically, it is normally associated or attributed to somebody called Grady Book, who came up with this, and James Rambo, who also came up with this, and also there's Ivar Jacobson. Well, this just is not very important for you, but it's just for you to know who came up with the UML analysis. All right. Basically, they were attempting to standardize semantic models and syntactic notations and diagrams of OAD, or to come up with a standard way of drawing OAD diagrams. Otherwise, everybody would draw their own things to represent a system. So they came up with the UML to create a standard which all designers and programmers can use to draw and represent a system, such that if you sit together with other programmers or designers, you can and draw a diagram. Everyone else on the table can actually understand what you've drawn and what each particular visual artifact, whether it's an ellipse or a rectangle or a rhombus or a parallelogram or a link or an arrow or an arc, everyone around the table can actually understand everything you've drawn. Yeah, so that you can actually, so that there is actually a common standard of representing object-oriented systems. So basically, that was the idea of coming up with the language, the unified modeling language, coming up with a standard for drawing systems. That is why if I give you a question and I describe for you a system scenario and I tell you represent this using a state transition diagram, there can only be one way of representing. Okay, in the way that I showed you, there can only be one way. A rectangle, okay, a rectangle is a rectangle. A finite rectangle is a finite rectangle. A smooth rectangle is a smooth rectangle. A link or an arc is a link or an arc, and it means something. Labeling, a label should mean something. In other words, if you draw something outside from what we have learned, then that is not a state transition diagram in that particular case. Why? Because all UML models are a standard of a system. Okay, they are standard, meaning that all of us should be able to draw the same things or represent the system using the same things. So all of the diagrams that we've been able to draw up to now, they are all UML models. Okay, it is only that some of them are used in dynamic modeling and some of them are used in functional modeling, as we shall see even as we continue with the other UML models, which we are going to study from today. Okay, like state transition and state chart, they belong to dynamic modeling, right? Like to show the different states, how an object changes from state to state in its lifetime. And then functional modeling, we drew the data flow diagram, which shows the processes. Okay, so what we are going to be doing, we are going to be drawing a UML model and then ask ourselves, does this belong to, or you ask yourself and you interpret, is this model, is this a functional model or is it a dynamic model? How do you know a functional from a dynamic? A dynamic model represents the different change of states, okay, of an object from during its lifetime, from one state to another. And then functional modeling is about, or functional modeling is about the internal processes of a system, how the system manipulates data, inputs, processing, output, and storage. Okay, so as we are going to be drawing these UML models, you are going to be interpolating it and try ask yourself, is this a functional model? Is this a state, is it a dynamic model? Okay. Now, just a minute. Okay. Just a minute. Just a minute. Just a minute. Okay. So systems and models in UML, what are some of the things, what are some of the major elements? What are some of the major elements or some of the major things? Let me share the screen. What are some of the major components of a UML model? Some of the components are as follows. A system. A system is basically a set of elements that work together to perform a particular given task or to meet a certain objective. So for instance, if we say a library system, we are just talking about a system that enables different library activities to happen, different related library activities to happen. If you say this is a system for computing student results, it's basically a system that allows different related activities to happen so that unanimously they can allow results to be generated, student results to be generated. If you say a car system is a system that makes up, it's a general description of the components that make up a car. Yeah, like the lighting system, the braking system, the accelerating system, all those other systems, all right? The GPS system, all those. If you talk about an autopilot system, it's a system that it's a it's a general description of the components that make up that particular system or that particular that particular system. So basically, a system is a set of related entities or elements that work together to achieve a common objective. Okay, and therefore, a system can be divided into subsystems, different smaller systems within the same system that makes the system complete. Then a model is a blueprint of that system. A model is a functional blueprint of that system. It basically shows how that system works, but itself, it cannot be used in real life. It is just used for demonstration purposes. Okay, so for instance, if a model is like an abstraction of a system, it's like a simplified abstraction of a system. Basically, it's a prototype. A model is a prototype. It's like building, before you build a house, you come up with what? An architectural plan. Before you draw, and that architectural plan can be a what? It can be a drawing, and it can also be a craft, something you've made, which you can actually present. All right. And you can actually see that house the way it looks like. It helps you to project how the real thing is going to look like. That is a model or a prototype. And when you want to create a program, when you want to develop a program, the first thing you do is what? You design that program before you develop. You remember the stages of program development in structured programming, right? So the functional, you look at, requirements, feasibility test, analysis and design, developing, testing and debugging, implementation and maintenance, right? And so in the area of design, analysis and design, there is a place of modeling. And that's now what we are talking about in object-oriented system analysis and design. We're talking about how to model object-oriented systems that use classes and objects. Okay, so a model is a prototype of the real thing. It's a prototype of the real program or the real system that is basically used to show how that system works in real life. It is used to project, all right? It is used to project how the system will look like or work in real life, okay? And a view is basically a projection of a systems model from a specific perspective. For instance, a system can be made up of smaller subsystems, all right? So if you create a model of one particular subsystem, that is basically what you call a view, a projection of a systems model from a specific perspective. For instance, if you are developing a system for computing student results for ZTech University, it may have different it may have different, let me admit these people that are joining us. It may have different entities in it. For instance, there will be a place for lecturers to enter marks. There will be a place for HODs to moderate the marks. There will be a place for the exams officer to view the marks and probably report back to the HODs if the marks are right or if the marks need some correction or some of those things, right? So that particular system has these different subsystems. So if you want to show or show people a particular entity, like the area, the entity for lecturers entering student marks, coursework and exams, that is a particular entity in itself, all right, that works, that has its own functions, it has its own data, it has its own variables, right? So if you want now to show people how that particular subsystem works, not the whole system, that particular one, the way it works, then that is called a view. But a model is a prototype of the whole system, all right? And that means that system plus its individual components. But a view is a projection of a systems model from a specific perspective. Then for us to draw conceptual models of UMLs, those conceptual models are models that you can conceptualize, they are just models which you draw, you can visualize, you can conceptualize, you can understand. Like when you draw a state transition diagram, that's a conceptual model. It's just a model. Conceptual is just a descriptive term. It doesn't mean a lot of things. It's just a descriptive term to mean a model which you can visualize. Just that. Like when you draw a state transition diagram, you can actually visualize. You can say, okay, this smooth rectangle, this is a state, this is a transition, this is another state, this is another transition, this is another state, and you can, because you've named every kind of thing that you've used there, then you're able actually to conceptualize what the system does or what the system is about, okay? Or a DFD, you are able to see, okay, this is a process, this is an input, this is an actor, this one is a direction of input, this is output, all right? This is a constraint. So basically, conceptual model is a model which you can understand, you can visualize. And a conceptual model is made up of just allow me, I'm having to multitask here to allow people to join us. Okay. All right, so a model can be made up of basic building blocks, rules, and common mechanisms. Now, any model that you draw will have these three particular elements: basic building blocks, rules, and common mechanisms. Now, what are basic building blocks? Basic building blocks, these are the basic entities that you use to draw that represent something that is very key. Basic building blocks represent key items in a model, in a conceptual model. Now, basic building blocks can be divided into three things, relationships, and diagrams. Things, relationships, and diagrams. Basic building blocks for conceptual model. What is a thing? A thing can actually be divided into four, and we are going to discuss each separately. So there are what you call structural things, behavioral things, grouping things, and annotational things. Structural things, these are the nouns of the UML models representing the static elements that may be either physical or conceptual. The structural things can be a class, an interface, a collaboration, a use case, an active class, a component, a node, an actor. Basically, structural things are those particular things, key things that you represent and name them using nouns. All right, for instance, when we were drawing state transition diagrams, we had these particular things like, or let's talk about the DFDs. We had an ellipse to represent a process, and inside of it, we'll talk about send money process. Send money process is a noun, all right? Send money process is a noun. It's a process. It's a noun. Send money is just an adjective to talk about what a noun is about, right? Send money process, right? So what you represent using nouns in a conceptual model are called structural things. And normally those are but they are the key things, like the ellipses, the rhombuses, the parallelograms that you normally use for particular things, key things, yeah, those kind of things, or even a rectangle to show an actor, to show a process. Such kind of things are called structural things. These are the key elements of a conceptual model that are named using nouns, and they normally represent either a physical thing or a conceptual thing, a physical element or a conceptual element. For instance, send money process is a conceptual element. It's a structural thing, all right? But if we are talking about in a state transition diagram, we talk about something like, for instance, in a state transition diagram of a library system, when we say book approval, or book shelving. Book shelving is a physical thing that actually happens. Shelving of a book, all right? Shelving of a book shelving. Yeah, that's a physical thing, okay? So basically what you represent using those particular shapes, apart from, listen very carefully, apart from arrows and arcs and constraints, all the other things that you normally present using those particular shapes, and we are going to have different shapes for different models. All those different shapes that you normally write something in it, in those shapes, inside those shapes, those are called structural things. They are representations of key elements of a model, okay? Then there are behavioral things. Behavioral things, these are the ones that are represented using verbs, and they represent the dynamic behavior over time and space. The two types of behavioral things are interactions and state machines. Now, behavioral things are normally used when we are dealing with state transition diagrams, when we are representing verbs, activities that are happening, that happen in a different time or space. For instance, when you draw a transition, you represent using a what? An arc. But the verb that you write there is a behavioral thing, okay? Like A, and then when you go to action and event, action is pick a book, event is presence of a book, action is pick a book. Now, that pick a book, whatever action you've written that shows that that is a transition, this particular action will make a particular, you know, the object to move from one state to another, from one state in a particular moment in time to another. It's called a behavioral thing. Behavioral things are represented using verbs, and they are normally used in state transition diagrams or other diagrams which we are going to draw, which show how objects move from one particular space in time, moment in time, to another. Okay, like you can say pick a book. So that pick a book makes that object to move from shelf state to borrowed state. All right, something like that. So pick a book will be a behavioral thing. Then grouping things. Grouping things, they comprise the organizational parts of the UML models. There is only one kind of grouping thing, and that one is called a package. A package. So when you combine different structural things, behavioral things, and grouping things together, you normally, structural things and behavioral things together, you normally come up with a grouping thing. For instance, you're going to find out that in use case diagrams, we are going to be drawing some certain things, and then those things we are going to label, we are going to all combine all of them in one rectangle. So basically that shows a package to group together, okay? Annotational things, these are explanations, the UML models representing the comments applied to describe elements. So annotational things, these are comments, okay? Annotational things, these are comments. So for instance, if you have a key, if you have a key, like in a state transition diagram, and there is a transition you have named A, So if you come down there and write, now write the events, action guards, actions, and those things under A. That's an annotation. Those are annotational things. You are commenting on transition A. You've just labeled A. So you are now commenting A, what happens in A. Okay. And of course, you'll find out that the verbs that you're going to describe there, the verbs of things that happen in a given moment in time, is also a behavioral thing. But because you're using them as comments, they are also annotational things. Hope that you will remember that. All right. Relationships. So we have come from, so we are in basic building blocks. Under basic building blocks, we are looking at things, relationships, and diagrams. We are done with things. So let's go to the next key thing in conceptual models called relationships. Relationships are connections between things. They basically show how different things, especially structure of things, how different structure of things associate to one another or associate with one another. Relationships. Now, there are 4 types of relationships in UML models. There are what we call dependency, association, generalization, realization. I think you can remember this term from before, from some classes in the previous sessions. Dependency, this is a semantic relationship between 2 things, such that a change in one thing brings a change in the other. The former is the independent thing, while the latter is the dependent thing. Now, basically, we are going to look at these relationships when we go to the UMLs themselves, okay? So a dependency is where one relationship, it's a relationship, it's a semantic, a relationship in terms of words between 2 things, such that a change in one thing brings a change in the other, okay? We are going to look at how those things look like. Association, these are structural relationship that represents a group of links having common structure and common behavior. Now, associations, these are normally relationships that are used when joining 2 structural things together, or 2 or more structural things together. Generalization, I think you do remember generalization and specialization from the hierarchy of classes and objects. Hierarchy of classes and objects, where we discussed generalization and specialization, where we say generalization shows is a relationship, or is a kind of relationship, or part of relationship. And specialization shows a made of relationship. Okay. Then realization is a semantic relationship between 2 or more classifiers, that one classifier lays down a contract that the other classifiers ensures to abide by. Now, this is one of our relationships that we are not going to be using. We're going to be dealing so much with dependency, association, and generalization. Okay. But if you are asked the 2 kinds of relationships that are used in UML models, dependency, association, generalization, stroke specialization, and realization. So then diagrams. So after relationships, we have diagrams. So we have things, relationships, and diagrams. So diagrams are basically a graphical representation of a system. It can be whatever you draw, whatever you come up with, like a state transition. That's why we call it a state transition diagram. All of those things, that diagram will be made up of things, relationships. It will be made up of structural things, annotational things, these grouping things, behavioral things, those things. So, and also it will be made up of relationships. And relationships, basically, I will tell you this, that relationships are normally shown using links, okay? Links, those arrows that you normally use, they show links. Those are relationships. They show that one thing is related to another thing in one way or the other. Like a process is taking data to this process is related to this actor, in that this process sends data to this actor. Okay, like in a DFT scenario. So the relationships in a nutshell are normally shown using links links, and these links can be arrows or arcs or straight lines. Okay, that is basically what you need to know for relationships. Then diagram is the whole model. Okay, like you can have a state transition diagram, a DFD diagram, and a diagram is made up of all those things and relationships. Okay, so it's a graphical representation. It comprises of a group of elements generally in the form of a graph. And UML, we are going to discuss the following kinds of diagrams. And we're going to draw class diagrams, object diagrams, use case diagrams, sequence diagrams, collaboration diagrams, state chart, which we've already done, diagrams, activity diagrams, component diagrams, and deployment. We are also going to add another one called a robustness diagram. Robustness, ROUBUSTNESS, robustness diagram. So it is also going to be included there. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. But because we've already discussed state chart, they are going to be 9. So 8, this minus state chart is 8 plus robustness diagram makes 9. So we have 9 diagrams to go before we finish the units. Okay, so those are the ones that which we are going to be drawing. So we are going to start with class and object just as we move on, as we continue. Okay, and as we said, every time we draw a diagram, you are going to tell me, does that diagram lie in a functional model, or does it lie in a dynamic model? Bearing in mind that a dynamic model is one that shows the change in state or the change of an object through different moments in time during its lifetime. And then a functional model shows the internal processes of that system, how data is sent, how data is received, how data is processed, and those kinds of things. Okay, so every time you draw a diagram, you're going to be interpolating that in your brain, whether it falls in a it is a dynamic model, or is it a functional model. Okay, then so we have looked at the different basic building blocks: things, relationships, and diagrams. These are the basic building blocks of a UML. But the model is not only consists of basic building blocks; it also consists of rules. So let's now discuss rules. What are rules? A rule is basically it's a semantic description of how the system should work harmoniously. It's a semantic. Semantic just means use of words. Semantics. It's a semantic description of how that system works harmoniously. Now, semantics, UML has semantic rules for the following: names, scope, visibility, integrity, and execution. Okay, which we are going to look at in the UML models or in the UML diagrams. And then also a conceptual model of a system also has what we call common mechanisms. So we moved from basic building blocks, rules, basic building blocks, rules, and common mechanisms. And the basic building blocks, we have talked about what? Things, relationships, and diagrams. And the things we've talked about, structural things and notational things, talked about behavioral and grouping things. Okay, and then relationships, we talked about dependency, association, generalization, stroke specialization, and realization. Then under diagrams, we've said a diagram is basically it's basically a graphical representation that has things and relationships. Okay, and then therefore we have talked about the different kind of diagrams if you are going to draw: class diagrams, objects, state chart diagrams, use case, deployment, robustness, component diagrams, activity diagrams, and such kind of things. So when now we are discussing common mechanisms are basically specifications, adornments, common divisions, and extensibility mechanisms. Now, we are not going to discuss this very much because what we need to do now is to draw. What we need to do now is to draw, because the best way of understanding all these is basically to draw those particular diagrams. Okay, so UML basic notations. Now this is where now we are going to draw these diagrams. Let's begin with a class diagram. Okay, let's begin with a class diagram. So I'm going to open another. So we are going to begin with class diagrams. Now, just a minute. So a class diagram. Now, a class diagram basically shows the classes that are in the system. Now, when we are going to be doing the object-oriented programming, we are going to get to a point where we are going to now to be dealing with classes and objects. So in OOSAD, now there's a way we represent classes and objects using diagrams, okay? And so classes, we represent them using class diagrams. Now, how do we represent, what is a class? That is the first thing to know, to understand. We had already discussed before, but we need to repeat. A class is basically an encapsulation. It is an encapsulation of data and functions. A class is an encapsulation of data and functions which can be inherited. Okay, so basically you can have a class called students, and in it you have admission number, you have units, admission number, course, and fee balance. And then you can have different objects for different students that actually share those particular elements of that class: ID number, course, and fee balance. So a class is basically a what? It's basically an encapsulation of data and functions that can be inherited. Now, how do we represent a class? Class is represented by using a rectangle, a finite rectangle, okay? And that finite rectangle will have three sections: the top, the middle, and the bottom section. We are going to see how that looks like. The top section contains the class name, okay? The name of the class. And then the bottom section, the middle section contains the attributes. Attributes are basically data. Okay? Like if in a class called students, you have data like admission number, ID number, and course. All those are what? Those are attributes. Those are data elements. Data elements are attributes. Then operations are what are computations that can actually work on data to provide output. Operations are functions. So for instance, you may have an operation for fee balance, computing fee balance. So you may have a function for fee balance. You may have a function for things like student performance, to compute student performance. In others, a function to compute the coursework, a function to compute the exam plus the coursework to give the final marks, and then also which computes the grade to give them an A, B, C, or D or fail, right? So those are operations. So when you're drawing a class diagram, you're going to be drawing using a rectangle, a finite rectangle, which has three particular parts. The top part is for the name, the bottom part is for the data or the attributes, then the middle, the lower part is for the operations, or what we call the functions. Operations are computations that provide output. Okay. Now, in a class, members of a class can either be public, private, or protected. Now, the reason I want to go very slow on this is because these are basically concepts that we're going to learn when we get to classes and objects in object-oriented programming. Okay, but basically, when we can say that a member of a class can either be accessed publicly, privately, or in a protected manner. So a member of a class can either be public, private, or protected. A public member is basically a member which can be accessed from anywhere globally within the system. But we're going to see how to represent that in code when we get to classes and objects, don't worry. And then a private member is a member that cannot be accessed from anywhere, from outside the class itself. And then a protected member is one that cannot be accessed from outside the class itself, but it can be accessed by child classes. Now, I know these things are foreign, okay? I know they are foreign, but we are going to do them in object-oriented programming, public, private, and protected. Don't worry. And the reason we are saying them at this level is just because whenever you are given a question in OSAD, you're going to be told which member is public, you're going to be told which member is private, and you're going to be told which member is protected. You're just going to be told. So that should not give you a lot of problems. So basically, if you're told that a member of a class, whether it is this particular member, X coordinates, if you're told that it is a public member, then you represent public members using the plus sign, okay? Don't worry about how public is presented in a program. We're going to learn that because we have not reached there yet in object-oriented programming, okay? For now, what you have to know is that a public member, you're going to be told. A private, you're going to be told. Protected, you're going to be told whether it's public, private, or protected. So just for your representation in a diagram, just know when you're told a member is public, represent it using plus. When you're told a member is private, you represent it using minus. And when you are told a member is protected, represent it using the hash. Okay? So this is a private member, this is a private member, this is a protected member, this is a public member, public, this is a public. Okay. All right. So that is how we represent a class in a class diagram. Now, we don't need to go to object first because we don't need to go to object because we are not going to draw object diagram. We are going to draw an object, a class diagram. So we have to pass all these and go all the way to drawing the class diagram. All right. So here we are. So okay, you are given a question like this. A bank has many branches, okay? And then we are going to draw our class diagram. Let me share a screen here. Let me share a screen. So I'm sharing this screen. This is basically one of the, see, these are the things that we've been drawing from the previous classes. I think you can remember. So we want to draw class diagrams. We have said that a class diagram should have the following. It should have the top part, the middle part, and the bottom part. So it's just one particular rectangle. I'm going to maximize and minimize. I'm going to group them and then arrange them in a manner that they look consistent. So this particular part is normally, the reason I've enlarged that way so that it can actually support different attributes. All right. So basically, I'm going to group them so that they can just be one rectangle. Okay, that way. So in a class diagram, this is how you represent a class. All right. This particular part, the first section, will contain the the first section will contain, let me add text. The first section will contain the class name, the class name. Then this second one will contain the attributes. Attributes are what? Data. Then this other one will contain the operations, what you call the functions. So this is how you, this is how this is what a class diagram normally looks. A class in a class diagram normally looks like. Okay. Then we are going also, so this is the representation for what? The representation for a class. Then for you to represent the links or the association, please mute your mics. For you to represent links, associations, or relationships, for you to present links, associations, or relationships, you use what? Link. You use arrows. You use arrows. So you use arrows. Okay. Okay. So I want us to have a case scenario where we are going to say, let me copy this. Example. So we're going to have this example. A bank has many branches. And then we can also say here represent using the what? A class diagram. Bank has many branches. In each zone, one branch is designated as the zonal head office that supervises the other branches in that zone. Each branch can have multiple accounts, and loans. An account may either be a savings account or a current account. A customer may open both savings account and a current account. However, a customer must not have more than one savings account or current account. A customer may also procure loans from the bank. Represent this using a what? Using a class diagram. Now, let us now go to now representing, or let's have just a short break. Let's have a short break, and then we'll be back. So we are going to continue from there. Let's just have a 5-minute break so that we can come and draw a class diagram, and I give you another question, we draw a class diagram, and that will be it. So let us now look at this diagram. We'll draw, draw a class diagram. So we have this scenario here. Now we are required to draw a class diagram for this scenario. A bank has many branches. In each zone, one branch is designated as the zonal head that supervises the other branches. Okay, that supervise the other branches. Each branch can have multiple accounts and loans. An account may be either savings account or a current account. A customer may open both a savings account and a current account. However, customer must not have more than one savings account or current account. A customer may also procure loans. Now, let us draw a class diagram. Now I'm just going to copy and paste this. I'm going to copy and paste that so that we can have something like that. Now what we are going to do is we are going to actually, this is going to be a class called bank. Okay, that's a class by itself called bank. So a bank is a structural thing. Okay, then what are some of the attributes or data associated to a bank? Accounts, customer accounts. That's a what? And I want to align them. So customer accounts is one of the data associated to a bank. So a bank has many branches. So a bank will have customer accounts. Each branch can have multiple accounts and loans. So loans is another associated to that particular, associated to a bank. All right. Let me try and use a better spacing so that they can fit there. Customer accounts and loans. Okay. Then what are some of the operations a bank can do? A bank can according to this question, a bank can add a customer, a bank can give loan. So add customer is an operation. Okay, and the operations normally end with that particular curly brace. Okay, give loan and such kind of things. So these are operations a bank can do. These are data associated to a bank. Now, the other thing is we now need to see this particular class called bank, we are saying that a bank can have many branches. A bank can have multiple branches. So we need to represent that using what we call the one-to-many relationship. So we're going to copy and paste this. So we are going to have sorry. So I'm going to have this just a minute. I'm trying to ungroup, okay, so that I can treat each as a what? As an entity by its own. So we're going to call this branch A, and then a branch from this info given here. In each zone, one branch is designated as a zonal head office, okay, that supervises the other branches. So we are going to have branch A, and we can actually call it, it's the zonal office, zonal head office. Mhm. And then we are told each branch can have multiple accounts and loans. So customer accounts, loans, okay? An account may either be savings account or current account. For a branch can give either savings accounts or current account. However, a customer must not have more than one savings account. So a branch can also do what? A branch can add a customer, a branch can give a loan, all right? And a branch can also do what? Register an account, okay? Add customer, register account. And it can also, a branch can give. So you cannot get a what? You cannot get a what? You cannot get a loan, or you cannot register for an account at just a bank. You have to be at a particular branch, okay? So let me just try and I'm trying to maximize this so that it can accommodate what I'm having. Good. So we have that branch. So I'm going to group them. I'm going to group them. And then what I'm going to do, I'm going to now, I'm now going to copy and paste these, because a branch can have the bank can have multiple branches, okay? So we are going to have another one here. So look at this. Let me rearrange them. I want to make sure that they actually fit in this. They actually fit in this particular page. Okay. right? So what I'm going to do, I'm going to show you now what we need to do here. So I'm going to have a link. Okay. Because links are used to show the relationship. Okay. I need to ensure that these links actually look like the way I require. Okay, then I'm going to draw an arrow. That way. Basically, this just says that a bank can have different branches. Okay, so as you can see, this is actually a what? It's actually a link just to represent that particular information. Okay, then we are told that what else should happen? So of course, this one we need to edit this because we can only have one zonal head office. So we are just going to call this what? Branch B. Okay. So I'm just ungrouping so that I can edit this information, branch B, that way. Okay. Because why? We only have one zonal head office. The others are branches. Okay. One of the branches are zonal, the others are normal branches. So that's why I've edited that. So then I'm going to go back and regroup this, so that they can be together. When I move them, they move together. All right. So then we are told each branch can have multiple accounts. Of course, we have talked about accounts, and we have talked about that. So we can also say a customer, okay, it says each branch can have multiple accounts and loans. An account may either be a savings account or a current account. So bank, two different branches. You remember the concept of generalization and specialization. So this is specialization, right? As we move downwards, that is specialization as we move downwards. So, or as we move across this way. So a branch can have a what? Can have different accounts. Okay, a branch can have different accounts, and also a branch can have different kinds of loans. So we are going to represent those as what? Subclasses. Unaona tunaenda tukibranch. Bank ndio the primary, the parent class. These are the child classes. Also, these ones will have child classes of their own. So we are going to copy and paste these, and then this one we are now going to call it So look at what I'm going to do. A branch can have a what? I'm just going to represent one of the branches. So I'm going to call this what? Account. Okay. So I'm going to call this account. And because of, in the interest of space, I'm going to actually minimize this. And then an account. What are the data that is related to an account? What they are? Customer name, See, an account should contain the customer names or let's call them customer details and type of account. Moja. And what can a customer do with an account? Customer can open an account. Customer can close an account. That is related to accounts, right? So we are going to join them here. So I'm going to now group them. So a branch can have an account. Any branch can have an account. So what I'm going to do, I'm going to show this way. Sorry, there's something wrong here. I need to ensure that this is a perfect rectangle. Okay. All right, so let me now group. So that's an account. Then what are some of the, so these, I'm now going to show what, I'm now going to show this particular relationship. Copy and copy, paste. And then we are going to have a line here. So whichever the branch, any branch can have a what? An account. You see that? And then we are going now to say that it is written here that a customer may, so an account will also now branch out. Account can actually have two, okay? An account can either be savings account or current account. So we are going to actually copy and paste this. So now this where now, I think I need to make these landscape orientation so that you can have more space. Sorry. Okay, let me just copy, let me cut and paste this, because if I have portrait orientation, it will affect all the other notes before it, the other diagrams before it. Well, so here we are. So we have an account can either be what? Savings or can either be savings account or current account. So basically, we are going to ungroup. So we can now edit this savings account. So savings account also will have customer details and type of account. Open a savings account will also have the same operations of an account, open account and close account, because it's just a type of an account. Okay. And then okay, it says here each branch must have multiple accounts and loans. So a branch can have accounts and loans. So of course, let's finish up with the accounts first. So let me finish up with the account first. Then I show you how we represent the loans. So copy and paste. Okay, sorry. I need to group them first so that I don't lose them during moving them. Copy. Sorry, group. So I'm going to paste this. So this is going to be what? It's going to be savings and what? Current. So I'm ungrouping so that I can now edit current account that way. So of course, let me group it back. Group that. Then, so an account can either be savings or current. So of course, I'm trying to arrange them in a way that you can actually, the arrows can come here. So copy and paste this. I copy and paste this. Hope you can see how this is working. Good, so I bring this one here. And then just copy and paste this. Okay. All right, there we go. So an account can either be savings and what? Savings and current. Okay. Then we are told each branch can have multiple accounts and loans. So there is multiple accounts there, and then loans. So a branch can also have what? Loans. So how am I going to represent loans? I'm just going to represent them here. There. Why there? Because it's what a branch can have. A branch can have multiple accounts and loans. So see, branch kama hii, branch A, branch B, each can have accounts. Now each can have what? Loans. So na copy and paste here. So this is going to be what? This is going to be loans, right? So I'm just going to ungroup and then now represent how this class called loans looks like. So all of these things are called classes, okay? Just a minute, just a minute, just a minute. Just a minute. Come back here. All right. So back. So here we have. I hope that you are following. The reason I kind of enjoy this unit is because it just helps you to think and represent these things in a way that is comprehensive. It helps you think. It's not just theory. It helps you think and draw. So this is loans, okay? Account, and this is loans, okay? So a branch can have what? Account and loan. An account can either be savings or current. Loans. So an account may either be savings, current, we have represented. A customer may open both a savings and a current account. However, a customer must not have more than one savings account. So here, look at this. We are told that a customer may open both a savings and a current account. However, a customer must not have more than one savings account or current account. So these are what relationship? These are, first of all, a bank can have many branches. So one to many. You remember those kinds of relationships? One to many, okay? One to many relationship, okay? You can also have it here again, one to many. A bank can have one bank can have many branches. That's the idea, okay? And then each branch can have multiple accounts. So one branch can have multiple accounts, but then because we have represented it using this way, we will use a many to many. In other words, many banks can have many accounts, okay? Many banks can have many accounts. Many banks or many branches can have many accounts. And also here, many branches can have many loans, can be offering many loans. Then when we get to an account, we are saying that a customer can have one savings. Customer can have one savings account. So what do you think we have not represented? There's something that we've not represented about customer, okay? Customer. So this is what we are going to do now. This is what we are going to do. So we are going to, let me see how I'm going to do it. Okay, so we need to represent customer, okay? So I'm going to go back to, okay, let me just finish up with the loans, and then now we go to customer so that I actually show you how this works. So loans, what are the kinds of data that are related to a loan? A customer may also procure loans from the bank. So loans will have customer details, will have account name, right? Account name. Then a customer can do what? Can procure loan. So procuring loan is actually the, we can also.
Excuse. Sorry,
Yeah.
I can't see the shared screen.
Oh, you can't see the shared screen?
Yes.
Sorry, let me share that. Okay, let me share. Are you not able to see?
Yes, we can see.
Okay, then let's continue. So as I was saying, I'm adjusting this class called loans. Okay, so I'm adjusting this class called loans. So it has these particular details. So I'm going to group it that way. So a branch can offer loans. A branch can also have many accounts. An account can be a savings or a current. Okay, and then now we are told that a customer can have what? A branch can have customers, okay? Because branch, if we are saying a branch has, we can add customer, a branch can come and register to a branch. Si mnaona hapa kuna add customer. So that means a branch, one branch can have many customers, okay? One branch can have many customers. So, so what I'm going to do, let me just do this. Basically, I'm just trying to create a new page so that we can have a trying to create a new page so that I can create more space to draw. Just trying to create more space to draw these things. Okay. Okay, well, I'm just trying to create more space. So we are saying that a branch can have many customers, as given in the question. A customer may open both a savings and a current account. So that means a branch can have many customers. So how are we going to represent customers? You're just going to represent it here. So we are going to copy and paste this. So this is customer. This is now customer class. Customer. So details, customer details, account name. Okay, let me just adjust this so that I may show you something here, because I need more room to show you what I need to show you. All right, so what can a customer do? A customer can register for an account. A customer can also do what else? A customer can procure what? Loan, right? Customer can procure a loan that way. So you can join this. Okay, so now I can group them. So group this. So a branch can have, I'm just going to show a one-to-many relationship. A branch can have many customers. So copy and paste this. Sorry. Right. Let me copy and paste. I need a very, very small, I need a short line, not a long one, just to represent it. So because we are showing, okay. We're going to show this way. One to many. We're going to show it this way. We'll need to have, first of all, a straight line. I need to see that this is a straight line. Straight line. Then you know how a one-to-many relationship normally looks like, right? So just going to show, even I'm not going to use a straight line, I'm going to use an arrow and then just indicate that will be okay. And then I will indicate here one to many. In other words, one branch can have many customers. And then so a customer can have what? We are told that a customer may open both a savings account. Have we done something about account? Register account, procure loan. Okay, yeah, that way. Okay. Is this grouped? Okay. So customer may open a both savings account and a current account. So how do we do that? So we can say that a customer can have many accounts, right? Because a customer can open both savings and current. So one customer can have many accounts, right? So we are going to show how a customer can have many accounts. So how are we going to show it? Using this particular diagram. So we're going to, let's start with a line. Let us start with a line. So we'll start with a line, just a line to show what is happening here that way. So see what I'm doing here. Okay, that way. And then what? An arrow. I think it's taking us a lot of time because we are drawing using Word. Otherwise, and then I'm going to come here and draw a line. Let me show you. Just a very, very small line. There. You see that line here? That line, but there. Then another longer line to connect these two lines, to connect these. So what we are saying, what this means is that one customer can have multiple accounts, or multiple accounts can belong to one customer. And then we'll have another one here. See that? Basically, what this means is that one customer can have many accounts. Okay, so I'm going to represent it somewhere. These lines basically means that one customer can have many accounts. Okay, but it says what? Customer must not have more than one savings account or current account. So one customer can only have what? Okay, so this line here is to show that one customer can have many accounts. But this particular one, this is for current account. It means that one customer can only have one current account, and also here. Also this one, okay? This particular one customer can only have one what? Good, yeah. So this particular one shows that one customer can only have one current account and one customer can only have one savings account. But line hapa, this straight line shows that one customer can have many accounts. Okay, that's why we have joined all these arrows, right? You see how that works. So a customer may also procure loans from the bank. I think we have already done that. So a customer can procure a loan, but it says a customer may also procure loans. So a customer may have a what? A loan. So we are just going to show that using our an arrow. Just that. Customer can procure loans. Okay. And then we can actually also show a relationship between bank and customer. One bank can have many customers, right? That relationship may also come here. Just trying to have a perfect line. Well, I'm not able to have a perfect line, so this is going to be what? One bank can have many customers. That's what we have there. So can you see how that looks like? Just a minute. One bank can have many customers that way. So this is a class diagram. This is a class diagram for that particular system. So I've shown all the classes. I've shown bank, I've shown branches, I've shown account, and then under account, I've shown the different accounts. Then I've also shown under branch, I've shown loans. Then I've shown customer who can procure loans and customer who can have two accounts. Okay, one for each. So that is a class diagram. That is basically the class diagram. So I'm just going to save it here. It's going to call it class diagram. Okay. So any question in the class diagram? Any question? Washira, Manasseh, Brandon, Karis, Awes, Hussein. Any question on the class diagram? Are you understanding? Have you noticed also that in this particular class diagram, we have not been told whether some members are public or some members are private or some members are protected. That is why we have not. That is why we have not included what? We have not included the plus, minus, and the hash. Okay. Any question? In fact, I've just noticed that this one should be here. This one should be here. One to many, that way. And on that particular arrow, that's where it should be. Aha. Any question? So if there's no question, then I can leave you with a question. There's no question, I can leave you with a question. So let me get you a question. Let me give you a question. Is that the question that I had? Okay, there is the question. I want you to do that question. Very, very fast so that now we can actually look at it. We can actually draw it together. So you can actually probably take a photo of that question so that or just, let me just leave it there so that you can actually do it, actually see it and do it. So that is the question. I want you to draw that question. I want you to draw that class diagram. And then take the shortest time possible. Let's see if by 12:30 you'll be done so that we can now look at it. Sure that you show the different relationships that are there. Ensure that you show the different relationships that are there and all those things, the structural things or whatever else. Just the same way we've actually done it in the previous question. This is actually simpler than the one we have just drawn. So I'm going to pause so that you can actually do that work. Then we continue. Now I want to leave you to do that on your own. I want to leave you to do that on your own, and if you have any questions, you will be able to ask me, and I will be able to guide you on anything that you need to know concerning class diagrams. So I want to leave you to do that on your own. And then we are going to resume with our classes next week. So from next week, our classes are going to go back to the big blue button. Yesterday and today, the big blue button could not be used because there was some orientation that was happening for first years, and they were using the big blue button. So meaning that they adjusted the big blue button in the system so that it can accommodate for orientation only. So that's why we were using Zoom yesterday and today. So tomorrow, I mean, from Monday onwards, from next week, I believe we are going to resume with big blue button so that we can resume with our other sessions. Otherwise, is there anyone with a question or a comment or anything you want to say before we end the class and I leave you to do that work? Any question, any comments? Any question, any comments? Any question or comments? All right, if there be none, then I will allow you to now go and do that. Draw the class diagram, and if you have any question, you can get back to me. So have yourself a good day, and enjoy your weekend. Ensure that you don't enjoy your weekend until you forget that you have work. So you work that. These are the same questions that are going to come in the exam. So basically, it is important that when you are given work, you do it. Okay. Yeah. So we're going to stop at that. And then you're going to meet from next week. Have a lovely weekend and keep yourself safe.